All right, today I'm going to show you how to balance in a chemical equation using what we call the guess and check method. Here I have a combustion reaction, C2H2 reacting with oxygen gas to produce carbon dioxide and water. The first step you want to do in order to balance an equation like this is I usually like to draw a line to separate my reactants from my products, and I write each individual element on both sides. If you have any equations that involve polyatomics, you want to keep your polyatomics together if at all possible. And then once you have your elements written down, you want to count the number of particles on each side. And so if we look at this side, I have a subscript of 2, so I have 2 atoms of carbon, 2 atoms of hydrogen, and 2 atoms of oxygen. On my product side, there's no subscript there, so it's understood that there's 1 atom of carbon, 2 atoms of oxygen, right? 2 atoms of hydrogen, and then we've got to add in this other oxygen to the 2 we already have. So I'm going to take that 2 and I'm going to replace it with a 3. Now, once we have that information, the next thing we want to do is do some simple multiplication to make sure that we have the number of particles on the left, my reactant side, equals the number that is on the right. And there is an order that we like to use when we balance equations. First off, we want to use, make sure any polyatomics are balanced, and then metals, nonmetals, hydrogen, and then we always try and save oxygen for last. We don't have any polyatomics, we don't have any metals, so I'm going to balance carbon first. Over here I have 2 atoms of carbon, 1 atom of carbon on this side, so I've got less carbon over here. So I want to take a look at, see what number times 1 will give me 2 carbons, right? And that of course is 2. So I'm going to put a 2 right there. And by doing that now, this 2 will distribute to both elements within this compound. So we now have 2 carbon atoms, and then we're going to multiply this coefficient times this subscript, and we're going to get 4 oxygens plus this one right here. That's going to give me a total of 5. Again, like I said, 2 times 2 is 4, plus this one right here is going to be 5 oxygens. So guess and check, it's checked off. We look at hydrogen. Hydrogen is the same on both sides, it's checked off. Now when we come to oxygen, here we have 2 oxygens over here on this side of my equation and 5 on this side. Well, there is no whole number that we can multiply by 2 to give me 5, so we have to use a decimal. In this case, we know that 2 times 2.5 will give me 5. So I'm going to put a coefficient of 2.5 right here for now. That tells me I now have 5 oxygens. So as we stand, this equation is balanced because I have the same number of atoms on both sides. And so any blanks I have, I like to replace those with 1s. Now I know what you're going to say is, well, you can't have a decimal as a coefficient. And yes, that is correct. This is like saying you have 5 halves of oxygen. It can't exist. So in math, what you probably learned, to get rid of a half, we multiply that half by 2, and that cancels it out. You're going to do the same thing here. We're going to take this coefficient and we're going to multiply it by 2. But the law of conservation of matter says whatever you do to one substance in your reaction, you must do to all of them. So I'm going to take every single one of my coefficients and I'm going to multiply them by 2. Because remember, we cannot create or destroy any matter. And by doing that, then we get a balanced equation that is in whole numbers. So what I'm going to do is replace it. 2 times 1 gives me a coefficient of 2. 2 times 2.5 makes 5. 4 and 2. And you can check yourself. I've got 2 carbons 2 times 2 is 4 carbons right here, 4 carbons right here, 2 times 2 gives me 4 hydrogens on the left, 4 hydrogens on the right. And if I look at my oxygen, 5 times 2 is 10. Over here, 4 times 2 is 8, plus 2 times 1, which is 2 right here. So 4 plus 2 gives me, or excuse me, 8 plus 2 gives me 10 on the right-hand side. And so there is your balanced equation.